The illumination of the falls has a really interesting birth story. The story goes, an individual is driving over one of the bridges that crosses a gorge in this giant lightning storm. They see the falls illuminated beautifully under the flashes of light, and they think to themselves, why can't we illuminate it like this every night? Why is it only in a lightning storm that we get to see the falls in all its beauty in the evening? I think it was this thought and the resulting push to illuminate the largest object ever illuminated at the time is really the birthplace of lighting design.
Interesting taking a step back and looking at the history of the falls and understanding that in the early 1900s you had lighting developed into a spectacle instead of lighting for the task. Lighting became this firework that could be controlled. In 1907, this gentleman named Walter Darcy basically for 30 days had 44 searchlights positioned onto the falls. Took these searchlights and arc lighting to a whole new level where he started lighting up all these architectural features that would otherwise be completely lost in the night and brought them to life for people to actually see and marvel at materiality that was otherwise lost.
Hi, I'm Linus McDonald and I'm the lighting consultant for the Niagara Falls Illumination Board. I work for CTV Television for most of my career as a lighting technician, a lighting director. The history of lighting of the falls has come a long way from the gentleman who back in the very early days first observed the falls in one night in an electrical storm. And the illumination started back in the early 1800s with a variety of various sources of light, shall we say.
Lighting has the ability to change and morph the form of something, change the color of something, apply a gradient to something that otherwise would be flat and white.
Right off the start of this project, we knew that we were going to be part of something very special, something that was going to last a long time and be viewed by millions of people across the world. This is a legacy project for everybody involved. As a team, we wanted to get it right, so we tested everything.
I think throughout the process of the project, we learned that the falls means so much to so many people. The locals think of the falls in a certain way. Source of income, it's a source of their livelihood. And I think that is what everything in life, or everything we light as lighting designers, whether it's bridges or buildings, we deal with that as designers. We deal with this idea that structures and objects mean different things to different people. And one of the cool things about light is that lighting connects people to those objects. And we talk about this lots when we do design presentations for clients. We say lighting connects. As an example, if an object or structure is blue, and blue is someone's favorite color, it connects them to it. When someone has breast cancer and an object or structure turns pink in honor of breast cancer, it connects them to that object.
Devising a plan, coming up with solutions for all the little issues that a unique project application like this needs and has never been done before. The best response that I've been able to come up with is it's not an individual person that comes up with a solution, but the team effort of presenting issues and then collaboration between each of the individual team players, using the best of all the thought patterns.
This journey began for us in October of 2014 when the Illumination Board issued an RFQ to many companies around the world to see if there was a solution to their problem. The team we assembled comprised of Salex, Mulvey Banani Lighting, Echo Electric, Sceneworks, and Stanley Products. So we researched and located a manufacturer with groundbreaking LED optics, 2 degrees, very tight beam. And we also paired it up with a LED driver that would maximize the performance. We used 1,400 of these modules on the project. Stanley worked with us to continue to improve their product even after we were awarded the project. We looked for different sources of LEDs to put into their module, tightened the beam in order to get the maximum performance out of it. They were able to do that with us and still meet the delivery dates that were required.
RFQ called for 3 times the amount of white light. So we determined as a team that we could do it with 72 of these Stanley modules. Paul and I found a marina in Innisfil that had a throw from one dock to another. It was 2,075 feet. So Paul stood on one end of the lake, and I stood on the other end of the lake, and I shone the light across the lake, and he stood on the other side with a reflective vest, and he would take a light reading. RGB, if you put them on, makes up white. So we had a calculation that determined how many of those true white LEDs could then be made up of the 3 colors to pass this mock-up test. We found an abandoned runway in Niagara region, and we put the mock-up fixture on one end of the runway, and we measured 2,100 feet to the other end. And Nick and myself were at the other end with light meters, while Echo and Scenework were at the other side with the team. And we turned this thing on, and it lit up the farm that was like a kilometer behind us. This thing was massive. Ed's team developed a mounting frame for the mock-up fixture, and we showed up on site the day of the mock-up. As a baseball fan, it was kind of ironic because it was the Game 5 of the bat flip game. We were watching the Blue Jay game while we were wiring up the fixture on an iPhone. We turned on our fixture, and you knew right away that there was no way that we were going to fail this.
My thought at the moment was, yes, you're going to fire one of those modules and line up across, and I thought, it isn't going to make it across there. Well, I had to eat those words, because when they turned the module on, there was no doubt at that moment that we were going to experience something that night that we had never seen on Niagara Falls. And in fact, we did.
It lit up the island because there was a man standing on the American side of the falls on a laneway or a viewing deck, and he had a light meter. The readings they got on that night from our fixture was 14-foot candles. So we had more than doubled the amount of light we needed to.
We went through a really long process of trying to convince the falls and convince the stakeholders that color changing and that the dynamic ability the falls has was an important thing to keep. To illustrate this, we ended up proposing a lighting concept of a sunset. Everyone got this idea that a sunset is a natural effect, is a natural wonder of the world. It was easy for them to explain to other stakeholders why the color changing was important. For us as lighting designers, it was an easy way for us to push the design ahead as well, because the sunset required gradients, which mean we now had to move away from this idea of just retrofitting the fixtures back into 21 zones, which they currently had, into what is now like 350 channels of control. The sunset drove how we did the color mixing to achieve the effect. The sunset drove how we mapped out the channels in the falls. It drove major modifications in the bracketry and the design of the fixture mounting methods to allow for a gradient, to allow for a bottom zone, a middle zone, and a top zone. And we worked together to get to a final result that I think everybody wants, the public wants, the Illumination Board wants.
My name is Michael Smolansky. I'm a professional engineer, and my position in Acelex is application manager. Very interesting project for me. So it's combined many years of experience and knowledge. I realized that these luminaries could be the best because I have good information about what we have in the lighting industry. So 150 years ago, the Niagara Falls, especially Canadian side, was very different than we see now. There is more than 100 AGI layouts had been created and calculated, more than 100. So in the beginning it was impossible, that we turned this to a possible solution, what we have now, what we could propose, and seems to me it's become to success.
So the challenge on this project is that we had to build the US side of the falls and the Canadian side of the falls in an AGI program. So of course there are no dimensions, so we had to take all the dimensions from Google Maps and build the falls in AGI. The second challenge was to try to duplicate what was existing at the falls, which was difficult because the existing World War II searchlights did not have IES files. So that required us to do some photometric calculations and take readings at the falls of what was existing and try to put it into the program to duplicate.
The original control structure was a copper backbone cable that was run, which had a directional bore from the upper escarpment down here into the canyon. And what we found is that that had to be redone because that infrastructure was decaying. The communication protocol, DMX, that comes down here is done through a fiber optic link that is linking the 3 individual sites of this project, which is Table Rock facility, the tower facility, Illumination Tower, and then the Illumination bunker down here in the canyon.
The control starts off in the tower with 2 rack mount strand Philips Neos, which are a computerized lighting console. Due to the distance to Table Rock and due to the distance to down here, we had to go fiber. At that point in time, we've got 2 via 5 switches, which take fiber in and push out network. From the network, we then go into opto splitters, which then push out DMX to the data racks. Each data rack has a quattro, which gives us 4 separate DMX outputs, which then go into the racks. The racks themselves, the first driver takes DMX in and then broadcasts it through the next 16. Each driver controls is 1 DMX channel. Each driver controls 1 of the 9 cell LED fixtures that you see.
But we had such a good team dynamic going, letting other people give input, kept everyone engaged in the project. I think keeping the conversation open throughout the process and managing that, managing everyone's emotions and making sure everyone feels involved allows for that.